We have decent knowledge on r's and r minus 1's complement. In this lecture, we will solve few examples on 1's and 2's complement. In first example, we have to obtain 1's complement of 1010, a binary number, and we already know r minus 1's complement. R minus 1's complement is given by r raised to power small n minus capital N minus 1, or I can write it as r raised to power small n minus 1 minus capital N. And we have to focus on this part of expression, and let's consider a situation in which base or radix is equal to 10. When base or radix is equal to 10, this part of expression will give us 999 all the way to n nines, because number of digit is equal to n. For simplicity, let's say we have 4-digit number, so small n is equal to 4, and we have 4 nines. If base is equal to 8, radix is equal to 8, this part of expression will give us 7777. If radix is equal to 16, hexadecimal number system, this part of expression will give us f, 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 f. And if radix is equal to 2, binary number system, this part of expression will give us 1, 1, 1, 1. So there is no need to solve this part of expression, because you have to perform conversion and subtract 1 from it, and eventually you are going to have these numbers. So what we will do, we will take our n, the number given to us, and we will subtract it from these results. In this question, we have to find 1's complement of 1010. It means we have to calculate r minus 1's complement. So I will take 4 1's, because I have 4-bit number, and I will subtract 1010 from it. 1010 from it. 1 minus 0 is 1, 1 minus 1 is 0, 1 minus 0 is again 1, and 1 minus 1 is 0. So I have 0101 as the answer, as the 1's complement of 1010. And let's take 4 NOT gates. Input of first NOT gate is 0. Input of second NOT gate is 1. Input of third NOT gate is 0 again, and input of fourth NOT gate is 1. Let's try to find out the output of these NOT gates. Complement of 0 is 1. Complement of 1 is 0. In the same way, we have 1, 0. This is the number given to us, 1010, given number, and 0101 is the 1's complement. So this is the 1's complement. So from next time when we have to calculate 1's complement, we will just take complement of the given number. Complement of 1010 is 0101, and this is the 1's complement. Now we will move to second example, in which we have to obtain 2's complement of 10111010. And if you remember, in case of 2's complement, we have to first find 1's complement, and then we have to add 1 to it. So let's first find out 1's complement. I will just simply take complement of the given number. So 1's complement is equal to 01000101, and then we have to add 1. 1 plus 1 is 0 with carry equal to 1. 1 plus 0 is 1. Then we have 1, 0, 0, 0, 1, 0. So this is the 2's complement of the given number. This is our answer. So this is all for this presentation. Now we will move to homework problem. In first homework problem, you have to find 1's complement of 100111, and in second homework problem, you have to find 2's complement of 110011. So these are the two problems, and in next presentation, we will try to find out 2's complement by a shortcut method. So see you in the next one.